खुल के बोला ना, गुड इवनिंग सर। गुड इवनिंग सर। गुड
गुड
इवनिंग।
इवनिंग सर।
गुड। ऐसा लग रहा है मरा हुआ है तू।
अरे नहीं सर।
जिंदा है ना? बंदी छोड़ के भाग गई क्या तेरी? हमारा।
अरे नहीं सर।
Hello everyone.
ए हाय, व्हाट्सअप।
हेलो।
Good evening, sir.
गुड इवनिंग।
Anil.
सौरभ, गुड इवनिंग इज लिटिल बिट डिफरेंट राइट? गुड इवनिंग सर, लगा बंदी छोड़ के भाग गए।
अरे नहीं सर।
अरे कोई नहीं सौरभ, छोड़ निकले तू। हे गाइस,
Saurav,
what we
Saurav is like, I'm here. I have 10 questions ready.
perfect. Let me finish this topic today. Your question will be solved by tomorrow, not today, because I have lots of things to cover in my handy right now. So till
ओके
this
सर।
point, we have covered the spanning tree protocol, guys. So we have seen that, right? We have seen that in the spanning tree, we have seen the behavior of the CST protocol. We have seen the root bridge election. We have seen the concept of the bridge ID, concept of the cost. Yeah, guys, please be on mute. We have seen the concept of the port rules, RP, DP, and blocking. We have also seen that whatever the states we have in the spanning tree protocol, like disable, blocking, listening, learning, forwarding, right? So in the listening and learning, we are not going to send any kind of data traffic. This is a very important interview questions. In a listening and learning, we are not sending any data traffic. In a learning, we can only learn the MAC address. In a forwarding state, we can do each and everything, right? Then after that, we have seen that how you can manipulate the root bridge, right? For example, by default, not by default, like for example, if the switch one is a root bridge and you want to make the switch two as a root bridge, you can change the priority. Priority always you're gonna change in the increment of 4096. The reason is that because of the 12-bit we have a VLAN, right? So you cannot change the priority one and you cannot make the two over there like that. You have to always choose the increment of the 4096. The default priority we have is 32768. That's a mid value, right? That you can change up to the 65535. This is the higher range. The lower is a zero priority, right? Then after that, we have seen that what was the, yeah, how you can perform the layer 2 load balancing, right? How you can utilize the PBST protocol, right? So yesterday we have seen that you can make a switch one as a root bridge for the VLAN number one. You can make a switch two as a root bridge, right, for the VLAN number 10, right? And you can make a switch three, right, as a root bridge for the VLAN number 20. So this is the way that you can manipulate the PBST protocol that we have seen that. Now, all these things that we have discussed, right, till this point, all this information, the cost information, root bridge information, bridge ID information, port ID information, right? All this information is exchanged through the one of the packet, and that packet is known as a BPD. So all this information are present in the BPDU packet, and this BPDU, because STP provide the loop-free topology, right? So STP create the loop-free topology. Let me write on this thing. STP create loop-free layer 2 topology, right? So to create the loop-free topology, we need to configure the, reconfigure, not the configure, we need to reconfigure the layer 2 network. And to reconfigure the layer 2 network, we need a BPDU. And that BPDU is called as a configuration BPDU. So whenever the switches are creating the layer 2 loop-free topology, they use the BPDU is known as a configuration BPDU. So actually you have a two types of BPDU. If you see, you have a BPDU has a two types. One is called as a configuration BPDU. This configuration BPDU comes in the picture when you configure the layer 2 topology, layer 2 loop-free topology. Another type of BPDU is called the topology change notification. Simply as the name suggests that whenever your topology will be changed, whenever the topology will be changed, a new BPDU will be generated. A new BPDU will be generated. That's called as a TCN BPDU. This name is suggesting is a configuration BPDU means what? I need to configure the loop-free topology. This BPDU is just telling you, hey, whenever something has changed in my network, I need to inform by sending the TCN BPDU. So take example. we have a switch 1, right? We have a switch 2. We have a switch 3. And we have a switch 4. Right? So I understood this concept. Switch 1, switch 2, switch 3, and switch 4. Right? I have a link between the switch 1 and switch 2. That's the fast Ethernet link we have. Each link has some cost values, right? And we can make this guys a 0/0 and 0/1. Same way we can make this guys a 0/1 0 to 0/1, right? And this guy also 0/0 to 0/1. So we have a links over there, right? Now let's take example. The MAC address of this person is by default we have a VLAN number 1 is configured on the every devices, right? So that's fine. So the MAC address we have we can call as A, and the priority that we have a 32769, right? We are going to add the VLAN number 1. Same thing, the MAC address of this guy will be B 32769. The MAC address of this guy will be, sorry, bridge ID will be C plus 32769, and the bridge ID for this guy will be D plus 32769. So D is a MAC address and the priority. So if the priority will get tied, the lower MAC address will become the root bridge. So in this case, what happened? The switch 1 is become the root bridge. So once the switch 1 will become the root bridge, this will become the DP port, this will become the RP port. Again, this will become the DP port and this will become the RP port. And again, this will become the DP port and this will become the RP port. So all this election that has done, it's based on the configuration repeat. That you can see that all the election, the root bridge election, the non-root bridge election, all this election that has done based on the configuration repeat. So there is no problem. There is no problem. This kind of topology is known as a stable topology. I call this topology is called as a stable topology because there is no changes is happening right now. But take example, what happened if this link goes down? Okay, so right now this interface in the, if I talk about the state perspective that we have discussed, that if you guys remember that in you have discussed the spanning tree state, right? If you discuss about the state perspective, the first state is called the disable. It means that there is no spanning trees running. Then we have a blocking, right? Then we have a listening. Then we have a learning. And then we have a forwarding. So if I talk about the state perspective, right? So this state is right now forwarding. Okay, this state is right now forwarding. This state is right now for, see, these are the interface rules. These are the STP states. These are the interface rules. These are the STP states. So interface rules are what? Interface rules, either it can be a DP, either it can be a RP, or either it can be alternate blocking. Right? So interface rules are different, STP states are different. So right now, these are the forwarding state. So what happens if this interface goes down? So if this interface goes down, normally what happens? It will jump to the blocking state, right? Or simply we can call it a disable state. So when this interface goes down, what happened? The switch 3, right, this guy feels that, hey, there's just something had changed in my network. Switch 3 feels that, hey, there is something had changed in my network. What is the role of the switch 3 now? He's a non-root bridge. He will generate the BPDU packet to the switch 2. This BPDU is known as a TCN BPDU because switch 3 feels that there is something had changed in my network. So that's why he will generate the topology change notification. Topology change notification. So he will generate the TCN BPDU. He will inform to the switch to, hey, there is something had changed in my network. What switch 2 will do that? TCN BPDU is a reliable BPDU, right? TCN BPDU is a reliable BPDU. Always focus on the name. If you understand the concept, understand the name, you will understand the topic. topology change notification BPDU. So this BPDU is a reliable BPDU. Reliable BPDU in the sense of what? And this BPDU can be generated by non-root bridge as well. So normally the configuration BPDU is only generated by, right, root bridge, but the TCM BPDUs can be generated by non-root bridge, because non-root bridge feels that, hey, there is something had changed in my network. So when the switch 3 is going to inform to the switch 2, hey, there is something had changed in my network, TCN is a reliable BPDU. So if this is the reliable BPDU, what happened? Switch 2 is going to send the acknowledgement. Switch 2 is going to send the acknowledgement, hey, okay, by sending the TCN acknowledgement packet. Same thing, the switch 2 is going to inform to the switch 1, hey, there is something had changed in my network, by sending the TCN BPDU. So the agenda, the goal of the non-root bridge is what? The goal of non-root bridge is to inform the root bridge there is something had changed in my network. The goal of switch 3 is to inform the root bridge there is something had changed in my network. So he cannot send master directly to the non-way. He has to follow hop by hop procedure. So he will first send to the switch 2. Switch 2 will again now send to the switch 1. Now again, what switch 1 will do that? He will give the TCN acknowledgement. At the same time, what happened? He will give the another BPDU, that's called the configuration BPDU. In this configuration BPDU, what he will do that? He will put the TC bit on. Topology change. So when the switch 2 will receive the TC bit, when the switch 2 will receive this BPDU configuration BPDU, the TC bit is on, what switch 2 will do that? Switch 2 will reduce the, right, MAC address aging time, which is by default 300 seconds, right, to the 15-second forward delay. 15 seconds means 15 seconds in the listening and say 15 seconds in the learning say. So we call it a forward delay is a 15 seconds. So when the switch 2 will send receive this packet, the configuration will be the TC bit on. Switch 2 will decrease the MAC address aging time from 300 seconds to the 1500 seconds, 15 seconds only. Again, the switch 2 is going to send the same packet to the what? Switch 3. When the switch 3 will receive the same configuration BPDU with the TC bit on, what he will do that? He will decrease the 300 to the 15 seconds as a forward delay time. So they will change the MAC address aging time from 300 seconds to the 15 seconds. Make sure that your TCN BPDU is a totally empty BPDU. BPDU does not contain any data. It's a pure empty packet. That's how the TCN comes in the picture. So whenever something had changed in the network, right? So non-root bridge is going to inform to the another non-root bridge, hey, something had changed in my network. He will give the TCN acknowledgement packet. Again, non-root will inform to the root bridge, hey, there's something in my change in my network. So what switch 1 will do? He will give the acknowledge. At the same time, he will give the configuration BPDU with the TC bit is on. So when the switch 2 will receive the TC bit is on, he will change the MAC address aging time 300 to the 15 seconds. Same thing when the switch 3 will also receive the TC bit on, he will change the MAC address aging time 300 to the 15 seconds. So that every switch, right? Why they are changing this timer? So that every switches is gonna update the MAC address table. So that every switch is gonna update the MAC address table quickly. Now, let me explain you this part in the different topology. In this topology, my agenda was just to explain you the part of TCN. So when this link goes down, sorry, when this link goes down, he will generate the TCN packet. He will give the TCN acknowledgement. He will generate the TCN packet, and switch 1 will give the TCN acknowledgement with the TC bit is on. But what is the role of the 300 second to the 15 second? Let's come over in the different topology. Now let's take example. We have a switch 1. Okay. And we have a switch 2 as well. Sorry, I'm so sorry. We have a switch 2. We have a switch 3 as well. Right? And let me change this name right now. Switch 2, switch 3, and here we have a link between the switch 1 and switch 2, right? And here we have a link between switch 1, 2 and switch 3. So take example, we have a 0/0, right? And we have a 0/1 now, 0/0 and 0/1, 0/0 and 0/0. One more thing, TCN acknowledgement is not a separate packet. Only we have a two types of BPDU. One is a configuration BPDU and one is a TCN BPDU, right? So for example, when the switch 1, switch 2, right, and switch 1, we have to take example, and there's a link behind this guy. So when this link goes down, understood this concept, he will send the TCN BPDU, right? He will send the TCN BPDU. After what happened? He has to give the TCN acknowledgement, TC acknowledgement, right? So this TC acknowledgement is not a separate packet. It's just a packet of the configuration BPDU. In this configuration BPDU, what happened? This bit will be on. This bit will be on. This is not a separate packet. Only we have a two types of BPDU, either your configuration or either your TCN. So whenever the switch 1 is gonna give the acknowledgement, they will just use the configuration BPDU to give the acknowledgement to the switch 2. Now, so we have a 0/0. Now understand the thing. So we have a PC1, right? And we have a PC2 as well. Copy and paste. And this PC is gonna connect with the switch 2 right now. And this PC is gonna connect with the switch 3 as well. So understood, this is the 0/2 right now. And this is 0/2. This PC has a MAC address A, right? The MAC is A, the IP is 1.1.1.1. The MAC is B, the IP is 1.1.1.2. Now understand what happened. When I'm gonna send the packet PC1 to the PC2, right? So now we take example, this is the root bridge. I forgot to mention this point. This is non-root bridge. This is non-root bridge. Right, so we have a DP port, D, D, R, R, and we have a D and we have blocking. So in the blocking port, we cannot send and receive any data traffic. We are only gonna receive the BPDU packet. So right now, take example, all my communication is happening through this particular path. Suboptimal path, right? It's not an optimal path. The optimal path should be like this way. So yesterday I have mentioned this point, right? The spanning tree creates a suboptimal path as well. So right now, what will be the MAC address table for all the switches? Try to understand. The MAC address table of all switches is what? Switch 1 has a MAC address table. Switch 2 has a MAC address table. Switch 3 has a MAC address table. So understand, in the switch 2 MAC address table, what happened? You will have a 0/2. The MAC will be A, right? Because I'm going to learn the MAC address over here, right? Same thing. On a 0/0, I'm going to learn the MAC address A. Now I'm going to forward the packet to this guy, switch 3. On the 0/1, I'm going to learn the MAC address A. Now I will send the packet to this guy. Whenever the reply comes in the picture, when the reply comes in the picture, switch 3, I will learn the MAC address 0/2 MAC B. I will learn the 0/2 0/1 MAC B. I will send this packet to the switch 2. Switch 2 will learn the 0/0 MAC B, and he will send this packet to the PC. So now we have all communications fine. There's no issue. So take example, what happened if this link goes down now? So this is the MAC table that we have. You can see that on every switches right now. Take example, what happened if this link goes down? Not sorry, this is already a blocking port. I'm so sorry. Take example, if this link goes down. What happened in that case? Understood this concept. If this link goes down, this is the non-root bridge. This is the non-root bridge. This non-root bridge does not have an ability to inform the switch 1 right now, hey, there is something had changed in my network, because it doesn't have a connectivity with the root bridge now. he lose the connectivity with the root bridge. The switch 3 has lose the connectivity with the root bridge, and from the blocking port he cannot send the data. So what he will do that? So switch 1 feels that there is something had changed in the network. What switch 1 will go? Switch 1 is going to send the TCN BPDU, right? When this he's going to send the TCN BPDU with the what? TC bit will be on. So when the switch 2 will receive the TCN bit with the TC bit on, what they will do that? They will change the MAC address aging time. Switch 2 will change the MAC address aging time from 300 seconds to the 15-second forward delay timer. Same thing, when the switch 3 will also receive that, they will change the MAC address to 300, so 15-second forward delay time. Why they are changing that? Take example, if they are not going to change it, take example, if they are not going to change it, then what happened? If I'm going to send the ping packet, right? Tell me one thing, 1.1.1.2, and the source MAC will be A, destination MAC will B. When this packet comes to the switch 2, what switch 2 will do that? Look the MAC address table. According to my MAC address table, I need to forward the packet to home. 0/0B, right? He will send the packet to the home, switch 1. When the switch 1 will receive the packet, he will say that, hey, I need to forward the packet to home, 0/1. Do I have this link right now? There is no link. So till 5 minutes, because the MAC address ending time is a 300 second, till 5 minutes, what happened? You have a black hole in the network. Black hole means what happened? Switch 2 feels that I have a good connectivity with the switch 1. He will send the packet to the switch 1, but switch 1 doesn't have a connectivity with the switch 3. All the black hole will be there. Black hole means what? The user feels that I have sent the data, but user 2 is not able to receive the data. So to avoid this black holing, right, we have introduced the concept of the TCN. This is the another one reason is what? When the link goes down, I need to inform to the root bridge. That's the one reason to introduce the TCN. Second reason is what? I need to reduce this timer if something is happening in my network, so that every switches is gonna change the MAC address table immediately instead of waiting for the 300 seconds. That's a use of this flag TC bit. Once the switch 2 will receive the TCN BPDU with the TC bit is on, once the switch 2 will receive once the non-root bridge receive the configuration BPDU with the TC bit is on, they will reduce the MAC address aging timer, so that every switches is gonna change the MAC address table, and based on that we will do the network. So once they will reduce the timer, then what happened? This will be changed now. So I have mentioned same interfaces. Sorry. Right? So what they will do now? So they will change the MAC address table now. So this is like, okay, now I'm gonna send the packet through this particular link. So 0/1, and again over here also 0/0. That's a use case of the TCN BPDU. If the TCN is not there, then you need to, if the TCN is not there, right, then you need to wait for the 300 seconds. It means that for the 5 minutes, right, for the 5 minutes, you don't have any traffic. Understood?
Yes, sir.
Questions, guys? Anyone has questions?
Once the port down, the blocking ports come to a root port, right?
Yeah, of course, that comes in the picture. All the LXM will be happening.
Okay.
Hello.
Yes.
I just want to know, is there any limitation in STP? Limited. I mean, how many switches it is supported? Is unlimited, or is there any limitation in the switches?
What do you mean by limitation? You are talking with a spanning tree perspective or like a normal real life perspective?
Yes, spanning tree purpose perspective. The limitation in the sense how many switches it is support. I mean,
you can put the any n number of switches, right? You can put the 50 plus switches in the network, but it's depend on how the question should be like this. I understand your question. Your question should be like how long the BPDU will be traveled, how hops the BPDU will be traveled. That depend on the diameter. So your question should be like this: how long your BPDU will die? You can put the unlimited switches. That's not a big deal. You can put the 10 switches, 20 switches, 40 switches, anything you can put the switches. But the question should be like this: how long my BP2 packet will be traveled from the root bridge to the n number of non-root bridge? So that's depend on the diameter. So normally your diameter in the BBST protocol is a 7. Got it?
Actually, what is the now diameter? Exactly what it is?
Diameter is like hops.
Exactly diameter is, yeah. Yeah, tell me, bro.
So like this is the 1 diameter, right? This is the 2 diameter, this is the 3 diameter from the root bridge. So root bridge is 3 diameters away.
Okay, now what's the maximum diameter it's supposed to hold?
7 you have in the PBST protocol. Are you there? Can you hear me? Hello?
Yeah, now I'm hearing, yeah. Can you
So
hear me?
you can put the n numbers of switches, right? But your traffic will follow the almost 7 to 7. The PBST has a 7 diameter, right? But you can change it. There's a something. Let me show you that. I think so. Something is here right now. Yeah. So I think so. This diameter is 7. Where's the command? Let me show you that in the VMware format. The default is 7, but you can change. That's not a big deal. But you can put the unlimited switches. That's not an issue. But your BPD will be travel till the diameter. There was a command, but I've seen that somewhere. Where's that? Diameter 7. Is that now? Yep. That's right. So let's take an example. We can go on this one. We can go with that. So determine the devices, change the police size. Just trying to summary. So, so you can see the span key beginner number 1. I can change, or we don't have command for that one. Should we? One this one. Then one is just some command as the one. Yeah, over here is there. So you need to make a primary, and then we have a diameter. So you can change up to 7. That's max you have 7. Understood? You can put the n number of switches in your network, but your BPD will travel till the diameter.
Okay.
Okay, so we were discussing about the TCN, guys. So the TCN is just gonna generate the TCN BPD, right? Whenever they feel that there's changes in my network. So the main agenda of the TCN is what? To inform the root bridge, hey, something had changed in my network. At the same time, what happened? They will flush the MAC address they will flush the older MAC address and they will learn the new MAC address. So this has just happened in just a forward delay timer. So 300 seconds is going to change with the forward delay timer. That's a 15 second. So simply you can see that in a TCN BPD, you only have these 3 fields. That's why we can say that these are the empty packets. We don't have any information in this packet, right? So whenever something had changed in my topology, they will generate the TCN BPD. Simple language, whenever your ports are moving from the blocking to the forwarding, right? They will generate the TCN. And whenever forwarding to the blocking, right? They will generate the TCN. So both the case, what happened? The switches feels that there is something had changed in my network. So have a look, either move ports into the forwarding state or move from the forwarding to the blocking state, right? In order, switch will generate the TCN BPD. So the switch continues sending the TCN BPD every hello timer interval until it gets the acknowledgement from the upstream switches. So for example, if the switch 3 is sending the TCN BPD to the switch 2, right? If switch 3 is going to send the TCN BPD to the switch 2, and if the switch 2 is not responding with the acknowledgement, it will retransmit the TCN at every 2 seconds. Right? So the major role of the TCN is what? So when the root bridge receive the TCN BPD, right, it send the acknowledgement. However, the root bridge will set the topology change TC flag on in the configuration BPD, which relate to the every other bridge in the network, all those other switches in there. This is done to signal the topology change and cause all the bridges to the shorten their MAC address aging time from the default 300 second to the forward delay, which is the 15 second. So the major role of TCN is what? 300 to the 15 seconds, so that every switches will update the new MAC table. Anyone has questions? All good in the TCN?
Hello,
Yep.
sir. This CCNA Volume 1.
No, that's not a CCNP. It's not a NA volume 1. It's NP. So in your network, right, we have 3 types of topology change, right? If I talk about in a network, you have 3 types of topology change. One is called as a, see, basically it's a 2 type. If you talk about the 2 types, we have a significant topology change, or we have an insignificant topology change. As the name suggests that insignificant means what? right? Topology will be not affected. Only the TCN will be generated. Insignificant is what? Topology will not affect, right? Affect. Only TCN will generate. So for example, if you have a switch 1 and if you have a switch 2, take example, and if you have a switch 3, right? And if you see over there, right? And this is these are the blocking port right now. So take example, this is the PC1 and this is the PC number 2, right? Understood this concept. If there's something had changed in this particular link, right? If there's something had changed in this particular link, is there any gonna impact to the complete topology? No, there will be no impact to the complete topology. If something is changed on this particular interface, if this link goes down and up, if this goes down and up, there will nothing impact to the complete topology. That's called as a insignificant. In this case, what happened? Topology will not affect, only the TCN will be generated. So if this link goes down, switch will generate the TCN. That's all. But the topology will be not changed. That's called as insignificant. In a significant, what happened? We have a two types, right? First is called as a uplink fast, not uplink fast. First is called a direct topology change, right? And second is called the indirect topology change. So in a significant, we have a two types. One is called the direct and another is called the indirect. So direct means what? Direct means what? A switch that has a blocking port. Listen to me. A switch that has a blocking port. Which switch has a blocking port? This switch has a blocking port. Switch 3 has a blocking port. If this interface goes down, right, this is called the direct topology change, because it is directly connected to the blocking port. Indirect topology change means what? Indirect topology means what? If the link goes down, that doesn't have any blocking port. If the link goes down, that doesn't have any blocking port. If you see the switch 1 right now, the switch 1 doesn't have any blocking port. This is the RP and this is the DP, right? It doesn't have any blocking port. So if this link goes down, right, then it's called the indirect topology change. So this is indirect, this is direct, and this is insignificant. So in all these three cases, right, the switches will generate the TCN BPD. So your direct topology and indirect topology will change the complete picture of the topology. Your direct topology and indirect topology, or we can say the significant topology change, will completely change your network. But insignificant will not change the complete network. So take example, what happened? So we have a, so this is the, we have a topology right now. So this is the insignificant topology, right? This one. So if this link goes down or up, if this link goes down and up, if this link goes down and up, if this link goes down and up, every time, whenever you remove the switches, the link will be off. Whenever you connect the, sorry, whenever you remove the PC, the link will be off. Whenever you connect the PC, link will be on. Whenever you remove the PC, link will be off. Connect the PC on. Remove the PC off. Connect the PC on. It will be continuously going, right? See, in the real network, many times you are removing your PC, right? You're shutdowning your laptop or you're turning on the laptop. So in that case, what happened? The switch 2 has to generate the topology change, TCN. What is the problem is happening in this case? The problem is happening if the switches is going to keep sending the TCN BPD to the root bridge, right? The root bridge informed the other non-root bridge, hey, there is something had changed in the network. Please change the MAC address table, MAC address aging table from 300 seconds to 15 seconds. So this will happen continuously. So to avoid this problem, right, we have a solution, right? To avoid this insignificant topology change, we have a solution. It's called the port fast. So if you enable the port fast, right? If you enable the port fast on this particular interface and this interface, we can simply call it the access port. If you're going to enable the port fast, in that case, if something is happening on this particular link, they will not generate the TCN. So on the port fast interface, there will be a no TC. On the port fast interface, there will be no TC. Another benefit of the port fast is what? Second benefit we have. This is the first benefit. The second benefit of we have, if you're gonna enable the port fast on this particular interface, right? What happened? It will skip the listening and learning state. So it is gonna skip the listening and learning state. What happened in that case? This interface will immediately jump to the forwarding state. He will not wait for the 30 second. He will also not wait for the 30 second. Immediately it will move to the forwarding state. So that's a two beauty of the port fast. By default, this feature is disabled. You need to manually enable it. Understood? So there's a solution is what? Of insignificant topology, we have a port fast. So with the help of port fast, what happened? If the link goes down and up, the switches is not going to generate the decent VPD. Second, we have what? Right? Let's take example. Let me remove this guy. I'll show you the practical. Let me show you this thing in the practical way. Cisco packet tracer. Right, so let me show you the how you can enable the port fast, and the link will be moved to the forwarding state immediately. No need to wait for the listening and learning. So if you have switch one, take example, if you have switch two, right, and if you see, if I'm going to connect the switch one and switch two, that's a trunk interface. So normally if you see that, they are going through the listening and learning state. So this is the amber state right now. If you put the command source span tree, it's listening right now. So it will wait for the 15 second over here, right? Then it will jump to the learning. And again, it will wait for the 15 second. After the 30 second, it will move to the forwarding state. So on this particular interface, on the trunk interface, if he is doing the listening and learning, that's fine, because on the trunk interface, it can be loop, right? Because switch one can also generate the VPD, switch two can also generate the VPD. But try to understand the PC, right? This is the end user, right? This end user will never generate the VPD, right? So it's better to, what we can do that, avoid the listening and learning state. No need to wait for the 30 second over there. So if you just connect this guy, let's say example, if I'm going to connect the PC1 to the 0/2, if you see this 0/2 is going through the listening and learning. Can you see that? Listening right now, 0/2. It will go to the learning now. So till 30 second, right, you will not send any kind of data traffic. 0/2 is learning now. It's forwarding now. So what I can do that, let's take example, you have PC0 right now, and I'm gonna go on the 0/3 port number, and I'm simply gonna enable the interface 0/3 spanning tree, right, port fast. So if you see that, he's also saying that error message, not error message, saying that on a warning message, hey, port fast should only be enabled on the ports that is connected to the single host. It means that a PC or access port connected to the hub, concentrated switches, bridges to this interface when the port fast is enabled, cause the temporary bridging loop. So if you're gonna enable the port fast, right, on the link that is connected to the switches, right, it will create a temporary loop. It's a recommendation to do that on the access port only. So let's take example. I just enable the port fast on the 0/3, right? So if I'm going to enable the port fast on the 0/3, it is not going to wait. It is not going to move to the listening and learning. It will jump to the listening and learning state. See, that it comes in the forwarding, right? So I'm not gonna wait for the 30 second. That's a beauty part of what? That's a beauty part of the port fast. That's called as even if the port fast is enabled. So right now there is no port fast, and here is a port fast is enabled, and there is no port fast is enabled. So if this link goes down, switch will generate the TCN BPDU. But if this link goes down, they will never generate the TCN BPDU. So that's a beauty case of what? That's a beauty case of the port fast. Second thing we have, right? Take example, what happened, right? A direct topology change. So what I told you that about the direct topology change. Where a switch if the port of the switch if the port of the switch is down and they already have blocking port, that change is known as direct topology change. So take example, in this case, what happened? If this link goes down, right? So this is the blocking port audit. If this link goes down, normally what happened? Remember the states, we have blocking, right? Then we have a listening, 15 seconds, then we have a learning, 15 seconds, then it go in the forwarding. So this interface will take the 30 seconds to move in the forwarding state. That's called the direct topology change. So if you have a look over there, let me show you this topology. So in this topology, you can see that we have a DP port. This is the root bridge right now. This is the DP port, this is the DP port, this is the RP, and this is the DP, and this is the blocking, and this is the RP again. So if I'm going to lose this network, right? If I'm going to lose this link, then what happened? Your blocking port will move in the forwarding state, right? How long it will wait? It will wait for the 30 seconds. So if you're going to enable the debug switch spanning tree events, and debug is spanning tree switch state, I can say that. And now if you see the source spanning tree right now, this interface is the blocking right now. What you can do that? I simply go on the switch tree and say that, hey, listen, I'm going to shut down this particular link, ETH0/1. If I'm going to shut down this link, understand this concept, what happened? This interface will take the 30 second. Can you see that? 0/0 is moving to the new root port. It's moving to the listening state right now, right? Generate the TC packet. And now I'm going to move in the learning now. So from the listening, this interface is going to the listening, spend the 15 second, then learning, spend the 15 second, and then it will go in the forwarding state after the 30 second. Once it will go in the forwarding state, what happened? What I told you that if the port will go to the blocking to the forwarding and forwarding to the blocking, in both the case, switch will generate the TCN. So now if you see, once I move in the forwarding state, what happened? I will generate a TCN from this interface. So normally, right, in the direct topology change, right, in the direct topology change, if this link goes down, this link will take the 30 second to come up. This link will take the 30 second to come up. To avoid this problem, right, because this 30 second is enough time, right, to avoid this problem, if there is a direct link failure, right, then port will take 30 seconds to come up, right? So to avoid this problem, we have a uplink fast feature. Again, these all features that we are talking about right now, the port fast, the uplink fast feature, these all features are a Cisco proprietary. So you cannot see on the different vendor. So these are just, right, port fast we have, right, the uplink fast we have, and another is a backbone fast. That's we'll talk about it now. So all these features that you can see, that these all features just to improve the convergence time of PBST protocol. Because the PBST is a slow protocol, right? So to improve the convergence time of the PBST protocol, we have all these features. So if I'm gonna enable, let's take example, let me up this interface now. Let's back it up, right? So this interface was down. I just turn on this interface now. So if you see that everything is working fine now. So spanning tree, do so spanning tree, you can see that it's in the listening state. Wait for some time. Let's go in the learning. And now it's going the forwarding. So once it's going the forwarding, what happened? Generate the TC. If you see now, this interface 0/0 is my alternate blocking, which is this guy. It's blocking now. This is the RP. What I can do that I'm just going to enable the feature. It's called the spanning tree uplink fast. Now I have enabled this feature, right? After enabling this feature, what happened? The default priority had changed. If you see that the default priority is the 32768, right? So now it will change to the 49152. And after that, we have a VLAN number. So right now, all they have a single VLAN. So VLAN plus one, it will become the 49153. At the same time, right, the cost also will be changed, right? So the reason it's changing that, so that this switch 3 will never become a root bridge. So spanning tree, if you see, the cost has changed by the 3000. Previously, the cost was 100. Now the cost is 3100. So the two things will happen, right? If you're gonna enable the uplink fast feature, right? Two things. First, what happened? It will change the cost by 3000. Sorry. Change the cost. Sorry. Change the cost by 3000 and increase priority by 49152. Why they are doing these two things? The reason is that so that Swiss Re can never become root bridge. Swiss Re can never become the root bridge. That's why we are changing the, not we are changing, that's spanning tree are changing the cost over there and the priority over there. So now if I'm going to shut down this link, try to understand. Now if I'm going to shut down this link, it will just take a 1 second, quickly, right? It will up the interface. If I'm going to shut down this link, interface E0/1, if I'm going to shut down this link, the blocking port will comes up in just a matter of 1 second. You can see that. If I just shut down this particular link, right? E0/1, what happened? Now E0/0, that's this one. It's come in the forwarding state right now. Immediately, I'm not waiting for them. Can you see that in listening and learning? Previously, if you see that, we had a listening and learning, right? If you go above, if you see, I just shut down this interface 0/1. The port has went to the move listening, then it went to the learning, and then comes the forwarding 30 seconds. Now we don't have listening learning over here. And this is happening because of the port fast. Saying that, hey, the spanning port fast feature is enabled for the VLAN number 1. And this interface 0/0, this interface is moving to the forwarding state because of the uplink fast feature. Can you see that? Uplink fast. So that's the beauty of the uplink fast. But take example, what happened? Let me remove this guy now. You can see this command, so uplink, so spanning tree summary as well, and it will show you that uplink fast is enabled. For which VLAN? VLAN number 1. So now you can see one thing. Let me remove this command, uplink fast feature. And what I can do that. So the priority is now become the normal. I just removed the no spanning tree uplink fast. Priority is normal right now. 32769, 32768 is by default plus VLAN number 1. Now what I can do that, let's take example, what happened if this link goes down. Now, if this link goes down, try to understand two things first of all. To understand the indirect link failure. So this is the direct topology change. Now we have an indirect topology change. Indirect topology change. If the port switch, if the switch doesn't have blocking code and somehow that switch goes down, then that failure is known as indirect link failure. According to the, not according, failure. This will take approx 50 seconds. To avoid this problem, we have a backup fast. So take example, understood this concept right now. Switch 1 has already informed to the switch 2, I'm the root bridge. Switch 1 also has informed to the switch 3, I'm the root bridge. So whenever, right, the switches is informing to the switch 2, I'm the root bridge, and switch 1 also inform the switch 3 as the root bridge. On this particular interface, they receive the VPD. On this particular interface, they receive the VPD, right? So switch 3 knows that MAC address A is the root bridge. And switch 2 also know that MAC address A is a root bridge. Now try to understand what happened. If this link goes down and this information, right? So whenever the switches will receive the information that switch 1 is a root bridge, they will store this information that A is a root bridge for the 20-second. For the 20-second, they keep this information. This 20-second is known as a max age time. So if you see, do so spanning tree summary, do so spanning tree. We have discussed this timer already, 2 seconds. Aging time we have already discussed. Forward delay we have discussed now. TCM, the another was of max age time, 20 seconds. So this information that we have received on this particular interface, that's called as a superior BPD. Superior means what? It's a best BPD. Or it's, we can say that it's a correct BPD, we can call it. And that I will store the information because this is the correct BPD, right? Also, we have received this BPD on this particular interface that has a switch A is a root bridge. I'm going to store this information for the 20-second because of the superior BPD. This is the superior BPD, best BPD we can call it. Right? Now what? Take example. I have this information, right, on this particular interfaces, right? Now what? If this link goes down, then if this link goes down, if the switch to, or we can say the non-root bridge, lose the connectivity, listen to me carefully. If the non-root bridge, that's a switch to right now, lose the connectivity with the root bridge, then what happened? It will itself say that, hey, now I'm the new daddy. I'm the new root bridge. And if the switch 2 will say that I'm the new root bridge, then what happened? They will inform to the switch 3, hey, I'm the new root bridge, right? So B is the new root bridge. by sending which packet? This is called as the inferior BPDU. Why we call as an inferior BPDU? Because we already have a superior BPDU on this particular interface. And switch 3 already has an idea that A is a root bridge. Switch 3 already have idea A is a root bridge. So that's why what happened, he will ignore this BPDU. Again, he will send the next BPDU. Hey, and the root bridge. And the root bridge. On the blocking port, I'm keep sending the packet. So totally switch 2 will send the 10 BPDU packet. Or we can say the 10 inferior BPDU. Once the 10 BPDU you have sent, or the 20 second, that's a max timer will be expired, then what happened? This interface will go to the listening state and then learning state. Total, it will take the 50 second to up this port into the forwarding state. And once this port will be moved in the forwarding state, then what happened? DP, RP, DP, and then we'll go in the RP again. Then what happened? Then switch 3 will inform to the switch 2, hey, listen to me. I already have a connectivity with the switch 1. And here is the A plus root bridge. A is a root bridge. Then what happened? Then switch 2 said, okay, that's fine. Your MAC address is lower. I'm going to consider is A is a root bridge. Then he will not send the any inferior BPDU. So if anything is happening, right, if the indirect link failure is happening, right, it will take the 50 second, have a look. So take example, I have a topology, right, switch 3 right now. I'll just go to switch 2 and I'm going to shut down this link. Have a look. ETH0/0. Right? I'm going to shut down this particular link. If I'm going to shut down this particular link, right? If you see right now, the switch 2 is a switch 2. If you see that those is span free, according to the switch 2, he's saying, hey, the root bridge is what? 100. The root bridge is 100 according to the switch 2. But once he lose the connectivity with the root bridge, I'm going to shut down. Same command, those is span free. Have a look. He's pretending like I'm the new root bridge right now. And what he will do that, he will keep sending the PPDU now. Hey, listen, I'm the new root bridge. Can you see that? Still, BPDU, I'm sending it. Still, wait for some time. Right, I have sent the 10 BPDU. Now this interface is moving to the listening and learning. I will show you the debug message. Hold on. Look over here right now, still the root bridge, which means that still convergence is going on right now. Actually, the root bridge this is the root bridge actual main, but the switch 2 has lose the connectivity with the root bridge right now. Then what happened? The convergence is going on. So till that time, the switch 2 is behave like I'm the new root bridge. Right now, this port is a blocking. Once this port comes in the forwarding state, he will inform, hey, the root bridge is A, not you. Then he will change the status. But this will happen for the next 50 seconds. Till that time, till 50 seconds, you will have no communication in your network. Your network is unstable right now. Your network is unstable. Still. It's taking a longer time, man. The one now. Hold on. My interface is still down. Oh, this interface is still down. Hold on, let me up this interface. I need to debug again. 1 minute. Hold on, this interface was down. This is fine. I'm learning right now. All good. Alternate blocking, and now let's down this interface back again. 80/0 side down, do so span tree, root, setting the BPD to the source 3 right now, I'm able to receive it. Still root, wait for some time. Root. So Swiss 2 is not pretending like, hey, I'm the new root bridge. I'm the new king in this network right now. But actually the root bridge is this guy. 0, 100 is the MAC address. 0, 200 is the MAC address, right? 0, 300 is the MAC address. Now he got to know that. Previously, he was claiming that I'm the root bridge. Now the Swiss 2 got to know that, hey, I'm not a root bridge because 100 has a lower MAC address than me. So till if you see how many BPDU, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9. Where is the 10? This one. 10. So 10, I have received the inferior BPD. That's not a superior BPD. Why we call as an inferior BPD? Because when he's setting the BPD, he's saying that, hey, 0, 200 is the root bridge. I already know that 0, 100 is the root bridge. This is the superior one. And when you are claiming that you are the root bridge, for me, you are the inferior. For the Swiss 3, you are the inferior, not the superior. So what happened till 22nd, right? I'm going to receive this BPD. Then what happened? My port will be moving listening, then learning, and then forwarding. So total 10 into 2, that's a 2 second is a hello timer. BPD timer, 20 second. 15 second is a listening. 15 second is a learning. Total is a 50 second. So if the indirect link failure is happening, right, the switches will take the 50 second to reconverse the network. But you do have an ability to change this behavior. You do have ability, you can remove this 20 second, the max is time. You do have ability, you can remove the 20 second, that's the max is time. You can remove this guy. How? By enabling the backbone fast feature. So if you're going to enable the backbone fast feature, you can avoid the 20 second outage. But still, you have to wait for the 30 second. In the direct topology change, we can remove the completely 30 second, right? So link will be up in just a 1 second. But in the indirect topology change, you need to wait for the 30 second. We can only remove the max is timer, not the listening and learning. So have a look over there. So what I can do that, let me up this interface now again back. No shutdown. One more thing, your backbone fast feature must be enabled on our entire network. So whatever the switches you have in your network, you need to enable the backbone fast feature on every network. So let's see. Do so spine free right now. I have still in learning state right now. Hold on. Forwarding, right? So let's go on switch one now. And I say that spanning tree, backbone fast feature. Same command I'm gonna do on every switches right now. Switch to, sorry. Uplink fast feature, you're only gonna enable on the switch 3, but backbone fast you're gonna enable on the every switches. So if you're gonna enable the uplink fast feature, your priority will be changed to the 49152 and the cost will be changed to the 3000. If you're gonna enable the backbone fast feature, nothing will happen. For the VLAN number 1, we have enabled the backbone fast feature, right? So now what I can do that right now. So if I'm going to shut down this particular link, have a look, still my debug is going on. So if I'm going to shut down this particular link, I will just send the one inferior BPDU, right? And after that, what happen? My code will move in the listening and learning. I just received the one inferior BPDU. Okay, I just move the code in the listening state. So previously, if you remember that, we had received this amount of BPDU. So this is the previous output. If you see that, hold on, let me show you this one. So if you see in the older output, if you see that we have received the 1, 2, 3, 4, 5, 6, 7, 8, 9, and then 10. And then my code was moving in the listening, then learning, and then forwarding. So 20 seconds over here, 10 into 2, 20 seconds, then 15 seconds, and then 15 seconds, total 50. But now, if you see, after I shut down this link, once I have enabled the backbone fast feature, right, what happened? I just received the one inferior BPDU. Immediately, I put the interface into the listening state. Immediately, I'm not waiting for the 2-second event, right? Can you see that? The 450000. And then 15 is what? Learning, and then now forwarding. So I'm just gonna spend the 30 seconds. So we have completely skipped this guy right after enabling the backbone fast feature. So simple, we have 3 types of topology change, right? Or either you can call the 2 types. In the 2 types, we can call the significant topology change, right? That's gonna impact the network. That's called the direct topology change, indirect topology change. For the direct topology change, we have a uplink fast feature. For the indirect topology change, we have a backbone fast feature. For the insignificant topology change, what happened? We just need to enable the port pass. In an insignificant means what? Topology will be not affected, right? Only the TCN will be generated. But if you want to avoid the TCN, you can enable the port fast feature. Anyone has any questions, guys, in the TCN? Again, TCN doesn't contain any data, right? That's a very also important point. And TCN is a reliable BPDU. TCN is a reliable BPDU. Questions? No? Okay. Then what I can do that now. The next one. Okay, the security, right? Security, spanning tree, security. Okay, let's do one thing then. We'll do the spanning tree security tomorrow, not today. Okay. Packet travel time from one switch to the other switch. It's 2 seconds. The BPDU you're talking about, it's 2 seconds. So we'll do the spanning tree. Let me save this paint file. So tomorrow we'll do the lab of the STP security, how you can enable the spanning tree security in your network. Tomorrow we'll do this lab, right? So tomorrow we'll done with the PVST, and tomorrow we'll jump to the RSTP protocol as well. Okay.
Okay, thank you.
Thank you. Okay, guys, see you tomorrow. Bye bye.
Thank you, sir.
Thank you.